Today we are adding and subtracting rational expressions, which again, our rational expressions is more work with our fractions. So let's look at our basic fractions that we used to do that didn't have any variables in it. For example, if I had 1/3 plus 1/5, the easiest way of finding a common denominator was to multiply my two denominators together. For example, I would have 3 times 5 here, and my 1/5 was already there, and I would have to multiply that by 3. By doing that, this gave me both common denominators of 15. So the only thing that we have to remember is what we do to the denominator, we also do to the numerator so that it is mathematically sound. I'm not changing the value at all to make my denominators the same. So what I'm left with on top here is 5/15, which we know was 1/3, and 3/15. And then we just have to add them together for a total of 8/15 as our final answer. We check to see if we can reduce that fraction at all. We can't there, so it's done. So now when we look at fractions that have variables, it's done much the same way. So in order for our denominator to be the same, we just multiply them together. So in the denominator here, I'm going to have x times y. And over here, I already had the y. I just have to multiply it by x. And now our denominators are the same. So whatever I do to the denominator, I also have to do to the numerator. So this here would have a y on top. And my x there, I have to multiply it by an x because that's what I did to my denominator. So now I just add them together, the numerators, and the denominators stay the same. So I have x squared plus y on top, and on the bottom my common denominator is x times y. Last thing, of course, is we have to have restrictions. X can never be 0, or the whole denominator would be 0, and y can never be 0. All right, let's try another example over here. All right, so our denominators need to be the same. They both already have one x in common. In order for them to be the same, they would both need to have two x's in common. So this one already has x squared, so I don't have to do anything to it as far as the x's go. Now this one only has one x, so I'm going to have to multiply it by one more so that they're the same. Whatever I do to the denominator, I also do to the numerator. Now we'll go back and we'll look at y's. This first term only has one y, and I need it to have 3. So I'm going to have to multiply it by 2 more y's, and whatever I do to the denominator, I also do to the numerator. And I don't have to do anything here because it already had the 3 y's. So now I have 5y squared plus 2x all over x squared y cubed. And that question is done, again with just stating our restrictions of x can't be equal to 0 and y can't be equal to 0. Here in example C, our x plus 2 and our x plus 2 is already common. So we don't need to multiply either by that already. We can just put it there because it's already common to both terms. Now here we have an x minus 1, but we don't have an x plus 5. We have to have the same common to all of them. So my x minus 1 I can leave, but that's also going to be needed over here to make them both common. Remembering whatever I do to the bottom, I do to the top. So now they both have x plus 2's. They both have x minus 1's. Now here, we need an x plus 5 made common. So I'm going to have to put that in the numerator as well. This already had a 1, and it already had the x plus 5. So now all 3 binomials in the denominator are the same. We just have to add and subtract our numerator. Add or subtract depending on what the sign is. So here we have x plus 5 plus x minus 1 all over those three terms that are common. So x plus 2, x minus 1, and x plus 5. This is a good spot to do restrictions here. So I'm just going to state that my x cannot be equal to negative 5, negative 2, or positive 1. Because if I substituted that into any of my binomials that are there, it would give me a denominator of 0. So I can add and subtract my like terms. X plus x gives me 2 x's, and 5 minus 1 is equal to 4. Again, we write out our denominator. All right, our last question that we're going to do together is D, and I'm just going to erase my restrictions here. Not that they're not important, but just so they don't get in the way of our next question. So here, when I look at this question, I realize that I don't have binomials in the denominator yet, so I'm going to have to do some factoring first. So I'm going to leave my numerators the same, because I'm not ready to add or subtract. And then I'm going to do some quick factoring in the denominator. So my magic numbers here would be positive 6 and positive 2. If it was decomposition that was needed here, then you'd probably want to do this off on the side, just like we did in multiplying and dividing rational expressions. So positive 6 and negative 4 are other numbers that work to factor that trinomial. So now let's figure out our denominators that are common. So they both already have x plus 6's. So we just leave it as is, x plus 6. Our first one has an x plus 2, but our second rational does not. So we're going to have to multiply that in, remembering the x plus 2 is already there, and we're going to have to multiply another x plus 2 on top. Our x plus 3 was already there. Here in the denominator, though, there was not an x minus 4, so I'm going to have to make that common, and whatever I do to the denominator, I do to the numerator. And the x minus 4 was there. So now I'm going to need to do some quick FOIL work that we now say as expanding. And the denominator stays the same. It's important to show all this work that you don't have any small mistakes along the way. And that way too, if you make any small mistakes, there's still part marks that can be given. So always show this work and show it clearly so your communication mark is also strong, not just your knowledge mark. X minus 4 there. All right, now we can add and subtract our numerator. Add and subtract like terms. So I see that I have 2x squared minus 4x plus 3x is minus 1x plus 4x is over here. Minus 1x plus 4 is plus 3x. Minus 12 plus 4 leaves me with minus 8. So I'll write this denominator again. And it's a good time now to write restrictions. So we're going to say that x cannot be equal to negative 6, negative 2, or positive 4. So when I get to this step here, it's a good idea to look at the numerator and see whether that can be factored at all. Because if it can be factored, you might be able to reduce your fractions a little bit further. Now here I remember for decomposition I have to do a times c, which is negative 16. And there's no two numbers that multiply to be negative 16 that add to be 3. So at this point here, I am done this question. I have brought up on the bottom the steps that we went through every time when we had to add or subtract rationals. You first check to see if you can factor. Then you find your lowest common denominator. You add and subtract your numerators. Factor the numerator again if possible. Reduce and state restrictions. So somewhere in your notes you're going to want to be sure you have those steps written down. I'm leaving you with question E and F to try on your own and bring into class tomorrow.